Section 2.6 talks about graphs of basic functions. And what we're going to be talking about mainly in 2.6 are piecewise defined functions. So it says the absolute value function is a piecewise defined function. It's defined by different rules over different intervals of its domain. Okay, so let me give you an example here, guys. This is what we call a piecewise function. Anytime x is going to be smaller than or equal to -1, that function is going to be defined as 2x. But anytime x is bigger than -1, we're going to be using x minus 1 to define the function. Okay? So in doing this here, the way we're going to do this particular problem that we have, because it's asking us to evaluate, is we're going to have to figure out over which intervals will we be using the particular function, okay? So for part A, it's asking me to find f of -5. So the first thing I have to figure out is the number -5, is that smaller than or equal to -1, or is it bigger than -1? Well, it's actually smaller than -1. So I'm going to use this part of the function. So I'm going to say it's going to be equal to 2 times -5, which is -10. Okay. Then part B says, let's find f of -1. So f of -1, well, -1 is still smaller than or equal to, because it's equal to -1. So I'm going to use that part of the function again. 2 times -1 is -2. Okay. Part C says we're going to find f of 0. So is 0 smaller than -1, or is 0 bigger than -1? Well, it's actually bigger than -1, right? So I'm going to use this part of the function. So I'm going to write 0 minus 1, which is -1. And then there is a part D. And D says, let's find f of 3. Okay. So is 3 smaller than or equal to -1, or is it bigger than or equal to -1, or bigger than -1? Well, it's bigger than -1. So I'm going to use this part of the function again. 3 minus 1 is 2. And so that's how I know which part of the function I'm going to use. Based on my input number, the number that I have in here will tell me which part of this function I should use. Okay. So let me scroll down to the next one. We're going to do the same thing. We're going to find f of -5, f of -1, f of 0, f of 3. So let me write those down. So part A says we need to find f of 5. Part B says we're going to find f of -1. Part C says we're going to find f of 0. And part D says we're going to find f of 3. Okay. Okay, so f of 5. So remember, when I'm using the number 5, I'm going to come back and I'm going to look at these pieces here. Okay. Is 5 smaller than -4? No, it isn't. Is 5 between -4 and 2? No. Is 5 bigger than 2? Yes, it is. So I'm going to use this part of the function. So 3 times 5 is 15. Okay. All right, let's do that again. Oops. Get my eraser. Okay, let's do that again. So now we're going to come back here. We're going to look at -1. Is -1 smaller than 4? No, it's not. Is -1 between -4 and 2? Yes, it is. So I'm going to use this part of the function. That part of the function says negative times whatever number I have here, -1. It's a positive 1. Okay. Let's do that again. Okay. So now I'm going to look at 0. Is 0 smaller than -4? No, it's not. Is 0 between -4 and 2? Yes, it is. So I'm going to use this part of the function again. Okay. Negative of 0. Well, the opposite of 0 is still 0, right? And we got to do that one last time so that we can find f of 3. Is 3 smaller than -4? No, it isn't. Is it between -4 and 2? No, it isn't. Is it bigger than 2? Yes, it is. So I'm going to use this part of the function, 3 times whatever number I have on the inside, which in this case is 3, and that gives me 9. Okay. All right, so now we're going to talk about how do I graph a piecewise function, okay? So we were going to graph a piecewise function. In this case, the function is defined in, the function is defined in two pieces, right? It's going to be x minus 1 anytime x is smaller than or equal to 3, and then it'll be 2 anytime x is bigger than 3. So let's do this. We're going to just make a little table of values, right? And we're going to pick numbers that are, say, smaller than or equal to 3. So let's take 3. Oh, I don't know. Let's pick 0. And let's try something like, I don't know, we'll keep it easy, -2. Okay. So now I'm going to take this value of 3 and I'm going to plug it in here. So 3 minus 1 is 2. I'm going to take 0 and plug it in here. 0 minus 1, -1. And I'm going to take -2. -2 minus 1, -3. And now all I'm going to do is plot those points. So when x is 3, y is 2. Okay. When x is 0, y is -1. And when x is -2, y is -3. Okay. And I am connecting these points here. Okay. And I'm going to make sure that I have a dot right there because it says it would be smaller than or equal to 3, and we plugged in 3. Okay. Now I'm going to make a new table, x and y. And anytime I pick numbers that are bigger than 3, my y values are going to be defined by this function. So let's pick something like 4, I don't know, and 6. I'm just going to pick a couple. So what is y? Y is 2. What is y? Y is 2, right? There's nowhere for me to plug in the x. So when x is 4, y is 2, and at 6, it's 2. So my function looks like this. So if you notice, guys, it's kind of a line that's coming up here, and then that line just evens out this way. Okay? And there's my function. All right? Let's go over here. We're going to do exactly the same thing we did before. So I'm going to make a little table of values here, okay? So anytime x is smaller than 2, I'm going to use this function here. So let's pick some numbers smaller than 2. 1 and 0 and say, I don't know, -1. Okay? So I'm going to plug in 1 here. 4 minus 1 is 3. 4 minus 0 is 4. 4 minus a -1 becomes 5. Okay? And so let me go ahead and plot those points. At 1, I'm going to go up to 3. At 0, I'm going to go up to 4. And at -1, I'm going to go up to 5. Okay? Connecting my dots like that. Okay? And then we'll do the same thing here. Anytime x is bigger than or equal to 2, I'm going to use this part. So let's pick 2, and let's say pick 4. Okay. So first thing I'm going to do, I'm going to take this 2 and plug it in here. 2 times 2, 4. Plus 1 more, 5. Okay. Let's do the next one. 4 times 2, 8. Plus 1 more, 9. Okay. So I know now that when x is 2, y is going to be 5. Okay. So I'm going to put that there. When x is 4, y is going to be 9. So this is 6, 7, 8, 9. So up here, right? Okay. And I'm going to continue going in this direction, right? Okay. So you notice there's kind of like a missing piece here in the middle, right? We might say, okay, well, what is that going to look like? All right. Remember when we did this part here? And we said as long as x was smaller than 2, and notice where I started off at. I started off at 1, right? I don't want you to think it's a -1, but I started off here at 1. So what we can do is we can say, well, what would happen if x was actually 2, and I plugged it in here? 4 minus 2 would be 2, right? So at 2, my y value here is going to be 2, but it's going to have an open circle because I still have all these numbers that are smaller than 2 that I need to connect. But here, this is an open circle because that part right there is open. Okay? So let me kind of show you what I mean. I'm going to kind of try to draw this again, but without using like just like one color. So my line would look, oops, let me erase this. My line would look something like this. Okay. So my line would look something like this. Right, coming down this way with an open circle, and then this part just going up. Okay. So one of the things, guys, when if you end up taking calculus or maybe even pre-calculus, they talk about functions being continuous. So this function here would be not continuous. Why? Because in order to get from this piece here to that piece, you have to jump over it. They're not connected, okay? We actually might even talk a little bit about that ourselves later on. Okay? All right. So let's try another one here. It says f of x is equal to negative 3 when x is smaller than 1. Okay? Smaller than or equal to 1. So 1, 0, negative 1. What is the function going to be equal to? It's always going to be negative 3. So at 1, I'm going to come down here to negative 3. At 0, negative 3. And at 1, negative 3. So my function is going to look like this. Okay? And then we say, well, when x is bigger than 1, it's going to be negative 1. Okay? So if I pick numbers like 2 and 4, my y values will be negative 1. Okay? And even if I were to pick the number 1, it would still be negative 1, but I would have to have that open circle right there. Okay? And so this is what my graph would look like. Again, not continuous, right? It's not going to ask you this right now, guys. I'm just kind of giving you just a little bit of, just giving you some extra info there, okay? So let me keep scrolling here. All right, so we got a little bit of a word problem here. Let's see if we can't figure it out. And it says swimming pool levels. The graph of y equals f of x represents the amount of water in thousands of gallons remaining in a swimming pool after x days. Okay, so let me get my pen working here. Oops. Oh, come on, pen. It hasn't frozen a while, and now it's freezing up. Sorry, guys. All right. Okay, so the y is the amount of water, and x is the number of days. Okay? All right. So let's answer the questions. Part A says, estimate the initial and final amounts of water contained in the pool. So the initial would be when x is 0, what's the y value? 50,000 gallons. This is my initial. Okay. And then my final would be, what, 30,000 gallons? Because that's the y value there. Okay. All right. Part B says, when did the amount of the water in the pool remain constant? What they mean by constant is it didn't change. So it didn't change when x was between, when x was between 0, oh, come on, there we go. When x was between 0 and 1, and it also didn't change when x was between 3 and 4, right? So guys, this is writing it in like using inequalities, but you can also write it like this, using interval form. Okay. Alrighty, part C. There we go. Part C. Oh, come on, pen. There we go. Part C says, let's find f of 2. Okay. So I'm going to come up here at f of 2 If it's right between 40 and 50, it looks like it's about 45,000 gallons. And we want to find f of 4. So f of 4 looks like it is 40,000 gallons. Okay. And then part D, D as in dog, says, at what rate was the water being drained when x was between 1 and 3? Okay. So what that's asking us to do, basically, guys, let me get my, come on, pen. There we go. Okay. What that's asking me to do is, can I find the slope right here? Okay, so yes, we can. Think about it this way. How much did it go down by? It went down by 10,000, right? Over a period of how many days? From 1 to 3, wouldn't that be 2 days? So wouldn't that be that we're losing 5,000 gallons per day? And this would be my part D. And that right there, guys, was 2.6.